In this basic training video, we're going to talk about LiveAlign. So LiveAlign is a tool that will allow you to create an alignment on the fly and just grab stuff. And then tell the software that this is the coordinate system you want to be in. I have a CAD model on screen just to show that the LiveAlign tool changes depending on whether there is a CAD model in here or not. So if you have a CAD model in here, you'll see that we have all of the regular alignments that you would normally do over here in the Home tab, initial, best fit, all of these, right? So in my opinion, they give you this ability to go ahead and use these in the LiveAlign tool. But in my opinion, what I would do is create these on the CAD model first and play live inspect if I was going to use those types of alignments, right? Which I cover in another video. Where a LiveAlign really shines is when you do not have a CAD model, because Play Live Inspect can essentially do all those same things, and it's a nicer workflow. So if I need to align to this part, but I don't have a CAD model, so let's assume I don't have CAD at all, and I'm just going to create some dimensions on this part. So I'm going to go into LiveAlign, and there are two different options, the interactive and then advanced method. Interactive is essentially like a 3-2-1. So if I go in here, since I have a really basic part, which you'll see here in a second,
plane.
I'm going to probe 3 orthogonal planes. And as I probe them, it's going to ask, is that plane considered the X, Y, or Z axis? So I'm going to say this is the Z plus axis. And then I'm going to probe another theoretical orthogonal plane. This is the X axis plus. And then another plane. Now, once I finish, it's saying, do you want to go into live geometry to probe features, scan, or live dimension, which will create dimensions on the fly as well. For the sake of this tutorial, I'm going to go into live capture just to show that we are aligned. So I come into live capture. I'm going to scan the part. I'm not necessarily collecting the most accurate scan data here. I'm just showing that the part is aligned. So you can see where those 3 planes are in relation to the scan data. If I get out, let's exit live capture and let it rebuild. You can see if I zoom in, there's my coordinate system right there. So I probed that top plane, I probed the side, and I probed this plane, and we aligned to the coordinate system of control X and then collected data in that position, right? So that is LiveAlign using the interactive method. A lot of people, though, need something a little more advanced than that. So coming over to LiveAlign Advanced method, the way to think about this tool is just like some of our other products, we have this idea of aligning scan data to the world using a 3-2-1, which is essentially what I did a minute ago when I used 3 planes. The first plane, the second plane creates a line, and the third plane creates a point. So 3-2-1 is a little bit redundant with the other tool, the interactive alignment tool, but where the power really comes in is this tool called XYZ. And what we do is we break apart the location of the origin and its directional alignments into separate components here. So there are a plethora of ways of aligning parts, right? And it all depends on how your CAD drawings, how your drawings dictate how you align the part. So today I already showed a 3-2-1 or a plane line point alignment. So what I'm going to do in this one is create what's considered kind of like a radial alignment. So when you're in here, the idea is that you can probe those features and then select them to create the alignment once you're done. So you're kind of creating the features and selecting them to create the alignment in this space. It is possible to use live geometry first. So go in and probe a bunch of live geometry, then come into LiveAlign and just select these things and then create the alignment. So you can do that workflow as well. Today I'm just kind of combining both of them. So the first thing I'm going to do is probe a plane. for that top surface. Then I'm going to probe a cylinder.
Point, plane, sphere.
And as I go around
Cylinder.
and collect more data, it'll eventually figure out that I'm probing a cylinder. And then if it questions exactly what it'll probe, what it's probing, it'll pop up with a dialog asking which one to probe there. Now, I'm going to intersect that cylinder with the plane to create my origin. That's going to constrain my position. Now all I need is just two different directions to constrain the rest of my degrees of freedom here. So what I'm going to do
plane
is grab that side plane and then create another side plane on the other side that I used for the 3, 2, 1. So once I do that, let me go ahead and put the device back. Once I put that device back, you'll see I can zoom in here. So I will grab the plane and the cylinder and intersect those. And you see that when I intersect those, it puts the coordinate system at the base. But that coordinate system isn't clocked in the right direction. So what I can do is I can say, I want the x-axis to be aligned with this plane. I want the y-axis to be aligned with this plane. Now you see that it flipped it. It's just making assumptions based on the vectors of the probe points. So then I can go ahead and flip that if I want to. Now if I hit OK, it creates the alignment. And now if I go to live capture, again to prove the alignment is done, you'll see that everything aligns with the data that's already there. Let it rebuild there. So there's my alignment. So you can see how there are just 1,000,001 ways that you can align. Like I could probe these two planes and then actually probe 3 planes here. This one, that one. Intersect all 3 of those to create a coordinate system over here, and that would constrain the position, and then probe this plane to constrain Z. Like there are just so many different ways you could go about doing it, but these are the building blocks to creating a live alignment.